Appreciate you telling me that. Because I have it going automatically, but I don't like to have it when not
I'm
doing
glad you do, because I'll go back and watch it.
it. Always,
It's helpful.
I just hate to have a lot of dead air at the beginning, and I sometimes forget, especially like my head is just ready to pop off. So much stuff going on. All right, so all right, so we're just going to follow that formula. So the distance is equal to, and 1 minus 2, and it really doesn't matter which one is 0.1 and which one is 0.2. You just got to have them. You can't change in midstream, so to speak. In other words, this is 0.1 and this is 0.2, but you could call this 0.2 and this 0.1 if you wanted to. You just got to match the x's and the y's together. Yes. You're supposed to know that. I give that. People that don't read these announcements. Yeah, I know. I've mentioned this 3 days now. See that?
Oh, 3:30.
Mm-hmm. Everybody tested, it takes 1:30 to test at the same time. We got room 20. December the 8th, yes. 1 week from tomorrow. All right, so then here, all right, and then we're just going to simplify it out. So it's -1 squared, and it's got the square in there, so that way these things are going to be positive, you know. So does that look good so far? Everybody with me?
Yes.
All right, so the distance between the x's is 1 squared. So this is 1. And then the difference between the y's is 3 squared, which is 9. So then it's the square root of 10. Okay, now the midpoint is basically just how you would calculate an average of two things. So let's see, how do they put it? It's it doesn't really matter about the order so much, but we'll just follow the same convention. It's going to be written as a point now. That's a comma. Okay. So that's the average of the x's and the average of the y's. So then it's 2 plus 1 over 2, comma, 3 plus, and it's -2 over 2. I think I wrote it backwards. It doesn't really matter, but let's just make sure. I mean, still add up in the same order. But, so then that's going to be 3 over 2.
3 over 2 and 1/2.
1/2. Good. So that would be the midpoint. And you know, this is why I like this Desmos. Oops. It's just that it allows you to have a visual concept of it. 2, 3.
So what us writing down, since it's gonna be on paper, do we have to put it in parentheses? Like, will you deduct points if it's in?
You gotta, let me know it's a point, yeah, so we wanna make sure you know, see, this is not a point, this is a length. a
Right.
distance. So the midpoint is actually a point,
Okay,
so we must write 1 and -2, I wanted to give you a visual. All right. So then the distance is from here to here. Okay. And then the midpoint would be, oh, you could just say, I put the midpoint in because it was 3/2. See, there's the midpoint. See, smack dab in the middle. And the distance is just how long that is. That's the midpoint. All right, so what was the standard form for the circle? X squared plus y squared is equal to what? So this is it right there. The R is the radius, and then it's X minus whatever H is, and then Y minus Q squared. All right, now for this, see, we got, so this would be H, and that's K. I think that's what they used in our book, but I can't remember. So then the formula is going to be X minus 4 here plus, see, there's a minus built in. So it's Y minus a -1, which is +1. So 3 squared. And maybe I said I should have probably done this up here on this, just to show you how it turned plus. So Y minus a -1 is Y plus 1. Okay. So that is the form as
so that's how it will stay, correct?
that's what they want. All right, this one takes a little bit of time because this one is, we have to use that completing the square thing. All right, because we got to get it like this, see? You got to get the X's like that and the Y's like that. So what I would do is put these together, the X's. And I'm going to say a little, put a space there. Then add. All right, so just let me know if you understand what I've done up to that point.
Why you put the -43? Is it because it was, you putting it behind what a 0 was at?
Because we don't want that number. That number doesn't help us in this process. Because what we need to have is we need to turn these things right here into perfect squares. All right,
Okay,
43 is just kind of part of the leftover, so it's going to go on the right-hand side. Because we're going to complete the square. So how do you find out, in this case, how to complete the square for the x's? Well, it's b over 2 squared. And in this case, b is equal to -12. So -12 over 2 squared is what? That's it, 36. So I'm going to add a 36 there. And if I put 36 there on this side, I also got to have a 36 over here. See, I have not done anything illegal. I'm adding the same thing to both sides. So then what's the number I need to complete the square for the y's? Oh, there should be a plus there. Okay. So what's half of a negative? -4 squared is? All right, so just take a look at that and see if it makes sense. If you need me for more explanation, then I'll be glad to fill in the blank. But we're basically done now, all the hard stuff. Because this now can be written as x minus 6 squared. Okay? That's what's called completing the square. We came up with a number that was needed, which is half of the x term or the b term squared. Half of 12 is 6. 6 squared is 36. We kept our equation balanced by adding 36 to both sides. Same thing here. This is y minus 4 squared. So what we've done is use the complete square to write the x's, anything with an x in it, as a perfect square, x minus 6 squared, and then write the y's. And then over here, we're just gonna do the numbers. I'm gonna use a calculator because my brain is stopped working.
It'll be 9.
Okay, that's what I thought it was gonna be, something neat. And there we got it.
So
the
do we leave the circle as 9 or do we break it down to 3?
Well, it would be 3 squared if you're gonna
It'll
do
be
it.
3
3
squared.
is 9. But
Right.
they're asking for what r is, so r is 3.
3 squared. Okay.
And it's because that's the formula is r squared. So r is 3, you're right. So we squared it, and then the formula, I guess you could say it's 9, but r. So this right here, the center is just 6 and 4. So, oh, this is almost the exact same one here. Then we'll get it out, but that's, the C is the center. I'm just trying to see if there was something that had that in there, but that's, yeah, there it is, see? So H and K, let me see if I can put it on the graphic for you. There it makes a little bit sense, or better sense. So see that? Always remember, the center is the opposite side. The negative is built in to the formula. So it's the opposite. So if it was y plus 4, then it would be a negative 4. And then, of course, this right here is 1, 1, 2, 3. See that? It's a line segment, but just trying to visualize. I'm not really. Segment. 1, 2, 3. That's your radius. So are we all clear on that one? All right, so remember, a function the best way that I know to think about a function is if it's a line, then we're all right. All right, because that's just a line. This right here is the absolute value of x. That's going to be fine. But there's a problem with these two here. Why is that?
Because it can be squared, right?
Jimmy, with the y, that's when you run into problems. So we already kind of know from looking at this circle that the circle breaks the vertical line test, because if you draw a vertical line, you're going to intersect it twice if you do it here. And this is a weird one. And here's the problem what you run into right there. And then, of course, this other one is a circle. It's got the x and the y squared. All right, so on this, evaluate, we're just going to pop that inside of it. Okay, see how this is going to do. This is technically where f of so what we're doing is just putting an x plus 2 for y for x, and then we evaluate it. This right here, again, I'm using that formula for the square. 2x times 2 is 4x. 2 squared is 4. It's just minus 7x minus 14. And then we'll just distribute, see what we come out with. So I'm distributing 3 to all 3 of those, and then I still got negative 7x. And this would be negative 6. So it's negative 14 plus the 8. And then what else can we put together? We can put together these and those. You get 3 x squared plus 5x plus 6. Any questions? Um, and like I said, is the formula sheet usually comes on the paper test. Like I said, it's been a year, 2 years since they given one, so that's usually the way they do it. And probably somewhere in here I could even see. Well, maybe they don't. I don't know them here. They'll have it on yours. If they don't, I'll write them on the board, but I don't know how they do it on them. In my 128 class, they put it in as one of the questions. Anyway, but it'll be a separate sheet. Like I said, if it's not, I'll write them on the board.
We on page 2.
On page, that was just page 1. So we got, okay, as long as we get kind of page 5, we'll be halfway, right? All right. So,
Yeah.
So again, domain. All right, now, except for the logarithmic functions, all functions are gonna be domain negative.
Negative infinity to positive infinity.
I don't know why they got that one going down. Oh, okay, I see. It's a dot over here. Okay, so we have to take this back because they got a little ringer in here. This isn't an arrow, it's stopping right there. Okay? And it stops at -4, and because it's a whole, it can't be included. It can't equal -4. But it still applies what I said is on a domain on a regular function. Not one of these special made kind of things. Negative infinity is your domain, and then your range will usually be restricted in some way. The logarithmic function is the only one that's different. It's usually swapped around. So this is negative infinity, -4 to infinity.
So with the range, would it be included? The -4 would be included, or it still would not be?
You don't need to worry about the range on this because you got this other line coming down. Because remember, you're just looking at the y. All right. So this thing going down here is eventually going to cover up all of the y in the negative direction. It really doesn't matter about this thing because this doesn't affect anything because, okay, yeah, it stops at -5, but on this side, it's going all the way down to negative infinity. So as long as we've got one of them that's going down, and then it stops up here at 4. And that is included because it's a turnaround point. There's no hole there. So it can be 4. And like I said, this is one of those things, like I said, if I hadn't been.
It wouldn't be written other way. Like, it wouldn't like, well, I would have put like 4 in there.
Okay, look at the number line.
Until it's negative. It's negative.
Because it's further in this direction, okay? Let's see.
Yeah, I probably would have put that
Yeah,
too.
it's easy to do. But it's important to be right because as you kind of see, look, all the negative signs are down there. So negative infinity is way off down there to the left. So that's gotta come first. 4 is right here. Yeah. And this is just a matter of looking at the particular one. So we're gonna go to x equals -2, see where it meets the line at, and it meets at 3. So when x is -2, y is 3. When x is 1, it's 0. X-intercepts is just where it crosses. So that would be here and here. So it's -3, 0, and 1, 0. Here's the y-intercept. That one's backwards at 0, 3. The intercepts by design are when you have an x-intercept, y is 0. Because it's on the x-axis, so no movement on the one. For the y-intercept, it's the opposite. When you're on the y-axis, you've got no movement on the x-axis, you're at 0. All right, so they're asking about increasing and decreasing and such. So this right here, it's not changing, so that's what we call constant. So from -4 to what? It's constant.
To 0.
Yeah, to 0, so they got a dot there. Okay. All right, so right here, it's increasing. Here it decreases, and here it increases. So the decreasing is probably the easiest one because it's just a one piece. So it's 1 over to 3. See that? That's decreasing. Like I said, if you look at this as a roller coaster, up there at that point of 1, 5, you're sitting in a level. Then once you go past that, you're going down and you're decreasing until you get to x is equal to 3. Yeah, that's right. You're looking at x. Now, the increasing, well, it's going from 1, because 1, I'm sorry, 0. Yeah, thanks. And I got a parentheses there because it's doing the same thing. They're telling us that at 1, it's constant. I'm sorry, 0 is constant. So we're not going to count that in the increasing. It doesn't increase till we get past 1. I'm sorry, 0. Oh, look at that one. It's the x we're looking at. And then it's increasing all the way up to 5. And then we're going to union. And then we're going to start over because at 3 is where it starts increasing again. And then it's going all the way over to positive infinity. It's going to be increasing. 5, what did I do? Okay, so 0. Here you brought up that about looking at x.
I was about to say it should be 1, right?
You're right. There we go. So yeah, increasing from 0 to 1, but like the y-axis is not there. So 0 to 1, it's increasing. It decreases from 1 to 3, and then increases again from 3 to infinity. Now, when they say a relative maximum, they're talking about the maximum value you can see. This thing right here is got an absolute maximum that's infinity because it's going to go way up there, but they don't ask about that. They're asking about, relatively speaking, what's the maximum? And that's this right here.
5.
1. Well, it's 5 when x is equal to 1. In other words, it's 1 comma 5, but they got it broken down. And then the minimum, well, it's also here.
It's 1 and then 3
So the value is 1.
and 3, right?
Yeah. Yeah, that's what they want. I mean, technically it's the same value of 1, but I think they
So
will.
do we do 1 and 1 or do 1 and 3?
Well, 1 is the functional value.
Right. And 3 will be the x value, right?
Yeah.
Okay.
The y is 1. That's what they're asking essentially. What point, in other words, what's y or f of x? And then at that point, it's when x is equal to 3. All right, odd, even. All right, so let's just put this in a nutshell. If a function is even, it's symmetrical around the y-axis for one thing. But looking at it, if all the powers are even, then it's an even function. All right?
So
This-
it would be even.
Yeah, because this one right here is actually would be another way of putting it is x to the 0. So that would be an even function. Because really the only power there is 5x. So see that a negative 11 doesn't change anything, but you see that it's symmetric around the y-axis. But you can also see that from looking at the powers. So this is even. Well, it's just what they want an explanation. This one right here is a straight line. So that's got x to the first power. Plus 9. So what do you think this is?
Odd.
It's not symmetric around the y-axis, but here's the thing we need to know and just double check. I would just say it's odd because it's got only powers, because that's x to the first power. But is this symmetric around,
It feels like on the 0.
the 0 is considered either odd or even. It's kind of neutral. So here's another way to tell. I'm trying to take the easy way almost. So this one right here is definitely, look, it's 5, 3, and that's a 1. Okay. So this one is odd. Now, probably what we wanted to do up here is put in the definition f of negative x. I'm just kind of showing you my logic on doing it. That's the textbook reason why. And the reason is over here, the same thing. for odd, f of negative x is equal to negative f of x. But this one's definitely odd, and you can kind of see it if I graph it. And then I'm going to go back and do it the textbook way. So that one is symmetric about the origin. So that's an odd function. All right. But let's do something here.
So would B be odd as well because of the one?
That's
Or
what I was gonna do. Let's double check it. Let's do,
okay.
let's use the definitions. So let's find f of negative x. I think this one's gonna be neither. But I'm not sure. Okay, so the x doesn't affect. So this is f of negative x. All right? And negative f of x is just throwing a negative sign in front of the whole thing. And these two things are not equal, so this one is neither.
And the explanation for that one would be because neither one is equal to the
Right,
original.
yeah, that's kind of what I put right here. F of negative x is not equal to negative f of x. Mhm. What's that? Because I'm negating it. That's the negative f of x. See, negative f of x. So there's the function. So I'm negating the f of x, which changes the sign from negative to positive and changes this one from a positive to a negative. And then these two things are not equal now. If this one had been, come out to, yeah, well, it's just like I said, it's not, it doesn't even close really. I'm making a mistake. I think it's fine. But that's how you, that's the reasoning behind this, because odd functions, they have to be equal. These two things have to be equal. And if you want to see it, I'll go ahead and do it on this one. For the even functions, you really only have to do half of the work. That's what it amounts to. On the odd ones, you got to do the f of negative x, and then you got to negate the whole function. So negative and negative, so that's positive 4x to the fifth. Oh, and plus I got to do the negative, I got to do the other one too. So I'm saying the odds are twice as much work. So that's negative f of x. So f of negative x
So that's typically saying that the signs changed as well, correct?
Yeah, you just gotta make sure that the signs for the odd one, that both the f of negative x and the negative f of x are the same. For this one, it's just a matter of the f of negative x is equal to the f of x. All right, so here, this is just gonna be positive because you got an even number of negative signs there and that one, so that's positive x to the fifth. Here's an even, I mean, an odd number, so that's negative 3x cubed. And it's negative x times 7 is just negative 7x. See these? These are equal. So that's why we know it's odd. Finding out whether it's even is just half the work, because all you gotta do is just plug in f of negative x. On the neither, you gotta do both if you want to double check. But that's what the reason why I told you about the powers. But anyway. Let's see what else we can get to. Then skip one, didn't
Yeah, we on number 9. We on page 3. Yeah.
I? All right, a piecewise function. Just remember the piecewise function, you gotta look at the x value and see which one of these pieces you use. This one right here is gonna be negative 10. That's less than negative 4. So what we're doing is negative 5. We're using the top function. So that's 53, I believe.
Yes.
Okay, this one is 8. So that's the second one. So 48 minus 1 is equal to 47.
That's 32.
Oh, I'm sorry. Something going crazy with my brain.
You got some food last night?
I got a lot of sleep. Like I said, I was just, I don't know, I'm just completely tired. Every time something going on, somebody wanted to do something.
Yeah.
The end of the semester, you know?
The last one we'll use the 4x minus 1.
What's that?
The last one we use in 4x minus 1 because it's
Yeah,
great.
because you gotta do the, this one is if it's less than negative 4. This is greater than or equal to, so yes, you gotta make sure you use the bottom one.
It should be 17. Yeah. All right.
Negative 17. All right, this one is, I wish I had a little bit easier on, but we can do it. You remember the difference quotient? You don't need the one with the limit, because so it's like ours. So that's the difference quotient. One of the things you should have formula-wise. Okay, so what we gotta do is we gotta take f of x plus h square the whole thing So that's gonna square that out. I'm gonna do it the quick way. X times H times 2. You can pull it out. And H squared plus minus 3x minus 3h minus 9. All right. Now, up at the top, over here, we're subtracting the original function, okay? And remember, we got to subtract all of them. We got to distribute to every one of those. And it's all over H. So now, anything that can be collected, we can. I don't think anything that can be collected though, like terms yet. We got to remember though, very important, and this is one of those things I find that students make mistakes with, is that when you subtract, you gotta apply that negative sign to everything. It's just like in that odd and even thing. To find out if it's odd, you gotta find f of negative x and then negative the whole thing. So negative x squared, negative 3x is plus 3x, and negative 9 is plus 9. And then when you do that, you're going to have a great deal of these go away. So these are gone, these are gone, these are gone, and everything else has an H in it. If you end up with some that don't have an H in it, that generally means that you did something wrong. And then we're going to divide everything by H. So H goes in negative 2x, H has negative 2x. Here, one of the H's is going away, so we're just going to have one H. H into negative 3, H is negative 3.
Can you show that formula one more time? It was F. Okay, let me write that down right quick.
Because this tells you the slope of that line at any given point. That's why some of these had, what was it? Some of these had the term limit on there. And in calculus, when you start getting limits, that's where they introduce to you this concept of the derivative. And that's what the derivative is. It's the slope of a given line at any given point. So rather than calculate the slope using that slope formula a billion times, you do it once, and then you can calculate it for any point. And then once you do it like this, and pain in the neck, if you take calculus, then they'll show you that how easy it is to do with the derivative, and why you should be thankful you got calculus instead of having to mess with algebra, because that's a lot of work compared to how you do it in calculus, where you basically use something called power rule and you find it like that. But anyway. All right, so here is this is the slope. They just happen to be used So the M, which is the rate of change, is the slope. Let's see, F, I'll just write it in terms of, but all that is just, and I know that our thing has got it, let's see. Let's see, that's what they're doing. That's just your Y's. So what we're gonna do, well, first of all, we gotta find out what f of x2 and f of x1 is. So, f of x2 is f of 1. So it's 1 squared plus 5 is equal to 6. F of x to the first to f of negative 3. Which is 9 plus 5, which is 14, right? So this is f of x2. So then what we're doing is 6 minus 14 over 1 minus 3. See how I got that? Like I said, it's just calculating the slope. The only thing that's different is that you got to find out what the y values are, what the functional values are, which is y. So that's your rate of change. Notice that they call this rate of change. And like I said, is that difference quotient is to find the slope of a line at any given point. The slope of a line, a tangent line is what they call it. But see, it's really the same thing. It's the same thing as this. This, you're just doing it for one point. Whereas when you do it like this, you're using algebra to find out a formula, and then you can just pop in any point. All right, so how should we handle this? All right, this is the one that we're just gonna do a thumbnail thing here. What's that? Yeah, that's translation. Let's see. But the x cubed. Let's see. That's how it looks. It's like this. Something like that. But no, I had it backwards. Sorry. But you get the idea. Okay. All right. So now what's going to happen is this is going to be a -3 shift this way. So in other words, this right here is going to come over to there because it's negative of -3. And then it's going down 4 right there. So this is going to be the new center right there. So this thing pulled down towards right there. that, down 4 over 3. Just always remember that it's the opposite sign. So if it's plus, you got to make that adjustment that it's -3. Okay? So just by itself, the -3 moves it in the opposite direction of the sign in there. All right, this one right here is the one that sort of looks like this. Yeah, I'm terrible at drawing this and stuff.
We will have to draw a graph for each one of these to graph it.
Well, it says graph dotted and solid, so. Do they have like a little thing for us to do it on? If they have that, might be better. Let's just see if there's something down on the next page. Yeah, I just want us to draw, but that's the square function, the square root function. It starts off at 0, 0, 0. So this is the one that looks like that. Square root function. And so what we've got is so there's the square root function. So let's look at this one. What's going to happen is it's negative, so it's going to be translated downward. Okay, the whole functional thing. So instead of the y being a positive, as it would be up here, they're negating, so it's going to come down. In other words, it's going to look sort of like this. That's the negative part. See that? Now that I've done it by, let's do this one for you. So you can see. So see that? It ends up making a mirror image on the x-axis. Now this right here is on the inside, but we got a couple of things happening there. It's a negative x, and it's also a +2. So the +2 means that we're going to shift up. But this negative flips it around on the y, so like that. And then it's going to be up 2. So let's just make sure we got that right. So that, so there's the +2 going in the negative direction. So I should have put it over here. So that would be 2.
So it'll be which one
This is just
from the drawing?
this is the one right here that it would be, because this one right here, I did them one at a time, the shifts. Okay, this negative thing in front, it brings it down like this.
Mm-hmm.
So in other words, it makes a mirror image by bringing it
Of
down
that one, right.
from the x-axis. Then this negative on the inside translates it, or not shifts, it reflects it on the y-axis. This negative x. So see up here, the x was positive, but here
Uh-huh.
negative. So it does a y translation, mirror translation. And then the +2 is inside, so it goes 2 in the negative direction.
So both of them will be on the positive side because this is on the positive side.
Yeah, I don't know. Something the way we have to do it dotted, but Anyway, this is right here is the absolute value one. That's the one that's like this. Okay, and that's 0, 0 right there. All right, so this right here is going to have everything. All right. In other words, if the functional value, if the value comes out, let's just say it was 2 in there. 2 minus 1 would be 1, and half of that would be 1/2. So it's going to have everything that's coming out. But then we're also adding 3 to it. All right. So basic shape is this. This is going to pull it 1 in that direction. This one is going to pull it up 3. And then having, let's see, it makes it, it's making this, it's making it fatter. So let me put that there. Okay, that's absolute value of X. All right. So this was plus 1 over, that's that one. And then plus 3 is up here. All right. Was it minus 1 or plus 1? Minus 1.
My,
Okay, so see, minus 1 plus 3. All right, so everything's going to get halved. So what do you think is going to happen? It's going to make it fatter, right?
it's gonna stretch it, yes.
Yeah, it's a, well, I forgot what they call it. Is that stretching? I think that's right. I think that's the word that it actually uses. See, that makes it fatter. So when you multiply it by a whole number or a number greater than 1, it squeezes it like that with a fraction, bends it out. It does the same thing with any function. It's going to make it fatter when it's a fraction. If it's greater than 1, it squeezes it. All right, so I'm sure that's enough for one day. So remind me, it'll be on page 4.
Yeah, we'll be on page 4, number 13.
I don't know if we have a chance to finish, but the stuff at the end is more fresh than you had. But bring any questions you got. What you got, Lance? Talking about a graph, square root of 2 what?
Square root of 2.
Okay, that's a minus X and that's a plus 2. All right. So what that's doing is the negative X is doing the Y translation. Because remember, the original one was. So what it's doing is that negative X is shifting, not shifting, reflecting on the Y-axis. If it was the negative was in front of the square root, it does it on the X, does it going down and down, Y-axis. Okay, now the translation is anything that's added to the X. All right, so this right here, that's this right here, that 2 right there is this 2. So instead of it starting at 0, it starts at X. So if we had just done the negative X, See that? This is the +2 right there. Which is, like I said, that's negative x minus a -2. So then that's why it's going in the positive direction. All right. I'm tired of it. You know, still got 2 more classes. I don't know if I'm gonna make it. I might be totally broken apart by the time I'll get back there.
You have a call?
Huh?
You have a call?
Drinking better than coffee.